In part 1, we have designed dipole antenna. Now we are going to add the sweep in the result of dipole antenna for application of GSM 900 MHz frequency, and we will shift from 0.9 GHz to 1 GHz, and we will see how we can shift this frequency, resonance frequency, to 0.85 GHz to 0.8 GHz. And let's see how the results are changing with changing the length of dipole and with changing the radius of dipole, or changing the each dipole length or radius respectively. In part 1, we have designed this antenna with following parameters. For these parameter of each cylinder, we have duplicated this, and similarly the parameter of the port, lump port, and similarly finally we have created a vacuum cylinder for radiation. Now I am going to, the result of this dipole was here. You can see that this is the operating frequency. This is the operating frequency band of this dipole antenna, 0.84 GHz to 0.95 GHz. Now I am going to add the sweep in the length of this dipole. DL, length of dipole. The actual length of this dipole is 150 mm of each arm. Now I have added the sweep in the length of dipole from 130 mm to 170 mm in the each arm of this dipole with the step size of 5. Press on add. OK. From here you can check the result. Now we will create the 9 different graphs for each value. For first value, second, third, 4 up to 9. Press OK. Now I am going to analyze. After completing the analyzing of this sweep, I am going to check the results. This was our original design for 150 mm dipole length. In that case, we have the dipole band was 0.84 to 0.95 GHz. Here you can see that. Now we can check for this is a bandwidth of this dipole antenna for 130 mm length. Here you can see that this band has been shifted. If we decrease the length of this dipole from 150 mm to 130 mm, this band value has been changed to 0.97 GHz to 1.09 GHz. Similarly, if we increase the length of dipole from 150 mm to 170 mm, the new band is here. You can see that this is new band. By increasing the length of this dipole antenna, the frequency is backward shifted 0.74 GHz to 0.84 GHz. This is operating frequency band for 0.8 GHz. In this way, you can shift the resonance frequency to a desired operating frequency band. Now we will see by changing the sweep, by adding the sweep in the radius of this dipole, what changes will occur. Similarly, add sweep in the radius of this dipole, whose characteristics is given. The actual radius of this dipole is 2.5 mm. I have added this sweep from 2.2 to 2.8 mm. I have analyzed already. Now check the result. Here you can see that little bit the bandwidth of this dipole is getting improved. This was the original. Now you can see that by decreasing the radius, the bandwidth is decreased 0.1, almost 1 to 5%. By increasing the radius, here you can see that by increasing the radius, this blue lines show that the bandwidth is little improved. Here you can see that the new bandwidth is 0.83 to 0.95 GHz, but previously we have 0.84 to 0.95 GHz when the radius of each arm of dipole was 2.5 mm. But this bandwidth will improve for a certain value of radius. After exceeding that limit, the result will be getting wrong. If I add the sweep in the length of dipole with this much, from 50 mm to 250 mm, let's check the result. By exceeding the limit, the result will be not accurate. You will see in this case. Here you can see that the matching is getting disturbed. But this graph at 90 mm. Here you can check all bands for all different frequencies. But here you can see that as the length of this dipole is decreasing, the band is shifting toward this direction, toward higher frequency, higher resonance frequency. If we add the sweep limit, if we increase the sweep limit from 0.2 to 1.5 above, we can observe furthermore result. And also you can see that the band here, you can see that the band are also much higher as compared to lower frequencies. Here is band this much. In next lecture, in complete antenna tutorial series, if you want to know the basic concept behind this and you want to know the theory of this dipole antenna and its parameter shifting, and if you want to know how I got the radius for a specific frequency, application, the radius and length of dipole, you have to check the antenna tutorial series in my channel.